Good afternoon. So before starting my presentation, I would like to introduce myself briefly. My name is Damien Arhan. I'm a first-year PhD student from Sorbonne University in France. My research is supervised by Professor Eric Fouache and Professor Cosmas Pavlopoulos, both professors at Sorbonne Abu Dhabi University. And I would like also to add that we have support from the Critical Infrastructure and Coastal Protection Authority of the Emirate of Abu Dhabi. And so I would like to present here this subject, our research, our methodology, and our first results and hypothesis. Before starting to develop the subject, I would like to discuss about general things regarding sea level change. Why it is important to study sea level changes. First, for a better understanding of the environment. Geomorphological and natural processes are strongly linked to the sea level variation. And for instance, if the sea level drops, it might lead to a global erosion for all hydrographic networks. Moreover, sea level changes may induce coast and shoreline lateral shifting, which are called marine transgressions and marine regressions. As a result, coastal movements induce coastal environmental movements. Coastal environment movements such as sapras, lagoon, or mangrove swamps. So sea level change is one of the most important parts of environmental history in coastal areas. The next thing is why it is relevant for archaeological study. Sea level study is important for the reconstitution of coastal landscape and palaeoenvironmental evolution. It is really meaningful to situate the archaeological sites within their environment and to determine, for example, if they were close to the sea during their occupation or not. For the case of the Arabian Gulf, and especially the United Arab Emirates, studying the sea level changes is even more significant because of the low-lying coasts, of the low depth, and of the tide. So a small sea level variation can induce an important coastline mobility and huge marine transgression, which can destroy some archaeological sites and make people move. It is also important for the Arabian Gulf because of the strong attractiveness of the coastal areas. As you know, environments such as mangrove swamps are very suitable for human occupation in a global region where living conditions may be quite extreme. So there is a significant human occupation along the coast in the region. And so because of this significant occupation and because of the mobility of the coastline, studying the sea level variations is really important in that areas. So now I would like to speak about the Gulf case. And what do we know about sea level variations there? There is few studies about these questions. And the main problem is that in most cases, these studies rely on few data. They lack precision and concern only limited areas, but the results obtained have been extended as generalities for the whole Gulf. The general situation, based on the review of literature, is the following. During the late glacial maximum, about 22,000 years ago, the sea level was located 120 meters below than today, and the Gulf was completely exposed, and the sea was located at the Strait of Hormuz. After the late glacial maximum, the global warming induced a static sea level rise. And we are talking here about the absolute sea level. So what is it? The static changes affect the world ocean with the same magnitude, and these changes are driven by world climatic evolutions. A global warming leads the static sea level to rise because a huge amount of ice from glaciers and inlandses melt, and because of the dilatation of ocean water with higher temperature. And conversely, a global cooling will lead the sea level, the static sea level, to drop. So in the Gulf, after the late glacial maximum, the static sea level rose and induced a massive and rapid post-glacial marine transgression, which progressively flooded the Gulf. And this transgression has been modeled here on the picture by Lambeck and others in 1996. So you can see progressively this marine transgression. And this transgression reached its maximum about 6,000 years ago. And then the global sea level remained stable until recently in the 20th century. But in several parts of the Gulf, many beaches and sedimentary and landforms located today between 1 and 3 meters above current sea level have been observed. That means that there are also in our area relative sea level fluctuations. So what is relative sea level? It is different from the absolute sea level. It needs to be distinguished. It is called relative, but here is the global situation and the most accepted model. Actually, this global situation is not really accurate and cannot be extended as the reality for all the Arabian Gulf. And even if this trend might be true, there are significant differences between close areas. And that's why we started our research in the Gulf, and especially in the Emirate of Abu Dhabi. So here is our study area. It extends over 350 kilometers, all along the coast of the Emirate of Abu Dhabi, from Asila to Abu Dhabi city. Thanks to the review of literature, to satellite imagery, and to fieldwork observations, we have identified 4 sectors that are geologically and geomorphologically homogeneous. The first sector here is between Asila and Huayfat. And this sector is characterized by Miocene limestone outcrops, narrow embayments, and peninsula. The second sector corresponds to the north of Sapramati. This is a large embayment with Miocene fluvial deposits and huge sapras. The third sector is between Jebel Baraka, Jebel Dana, and Ruwais. And this sector is characterized by diapir intrusion. Diapirs are salt domes like Serbanias. And eventually, the fourth sector is from Ruwais to Abu Dhabi city. This is a large region with complex lagoon system and coastal sapras. Thus, as you can see, there is a wide coastal morphological spectrum in the Emirate of Abu Dhabi, and it allows us to carry out comparative studies on different environments. So the first stage of our work is the geomorphological mapping of surveyed areas. The mapping is done by using topographical maps, geological maps, satellite imagery, and fieldwork observations. And here you can see one example of the geomorphological map that we produced, and this one is coming from Rara Island. This stage is really important to understand past and actual sedimentary dynamics and reconstitutes paleoenvironmental evolution. The second important stage consists in identifying and characterizing the geological and geomorphological formations and sea level indicators. Because when the sea level is stabilized, even during a short time, it will leave some marks on the coast. And these marks are sea level indicators. There are several types of indicators, such as cliffs, notches, and wave-cut platform, marine cave, sapra, coral reef, beach deposits, such as beach ridges, for example, and beach rock. And here you have one cliff with notches, and at the right, a beach rock. So if these indicators are located outside the normal formation zone, they are evidence of a former sea level. So we identify them during a survey, and we calculate their elevation above or below the current sea level with correction according to tidal data. Eventually, these indicators are dated, and we can try to establish local sea level chronologies. Beach rock is the main sea level indicator we have studied so far in the area. It consists of beach sediment lithified by carbonate cementation. Beach rock typically forms within the intertidal zone, that is to say, between high and low tide. And because of its intertidal location, it constitutes a relatively precise sea level indicator. It usually forms in the intertropical zone on the planet, and it has been largely used by scientists as sea level indicator in those areas. But so far in the Gulf, beach rock have not been really used as sea level indicator, even if it can be found in numerous places. So extending the studies to more beach rock in the Gulf will bring new precise data, and much more precise than the studies of beach ridges, for example. So I would like now to present our first results briefly, which have been obtained after a survey conducted in 2016 and 2017 in Ras Rumais Peninsula and Rara Island. So here is the global location, and it is on our first sector. Ras Rumais is the westernmost peninsula of the Emirate of Abu Dhabi, and Rara is a small island to the north of this peninsula. In both places, we identify and studied raised beach rock. Here is the location of 5 beach rocks, and here they are photography. This beach rock was studied and dated, and here are the datation. The datation was obtained by carbon-14 on shells. These results highlight several important things. First, beach rocks from Ras Rumais suggest a very late high sea level around 1,000 years ago, and this situation has not been recorded in any other works in the area. The second thing is that our results present different uplift rates, even between nearby positions such as Ras Rumais and Rara sites. And finally, our results do not match with the most accepted model used in the Gulf, made by Lombeck and others in 1996 and used by lots of other scientists. Thus, it suggests a much more complex situation. On this map, you can see some other works that have been carried out in the Gulf. And if we compare our data with the results from United Arab Emirates, our data are in black. And you can see in blue and red works from Sharjah and Al Quwain Emirates and Eastern Abu Dhabi, Sapra Emirate. And so if we compare our data, we can see that they show higher sea levels, sometimes with more than 1 meter of difference. Data from Saudi Arabia and Qatar are more consistent with ours. And it will seem to suggest that we have local dynamics and differences between areas. Thus, according to this situation, the glacio-hydro-isostatic dynamics may not be the only factor responsible for relative sea level variations. Diaperic dynamics might have small and localized impacts that which explain those regional differences. Indeed, the Arabian Gulf is characterized by important evaporitic deposits called humus salts and dated to about 600 million years ago. These salts form in extensive basins under very arid conditions. And because of the collision between the Arabian and the Asian plates, and because of the ductility and the low density of the salts, they may have flown laterally and vertically, and sometimes reaching the Earth's surface and forming salt domes, such as Sirbaniyas. So here you have just a quick modelization of how the salts can intrude. And here, in our satellite imagery from a diaper, Sirbaniyas. Thank you for your attention.